Okay, we continue with the review of exercise 1. We're going to number 5. We have marked the equal angles. We have marked the equal sides. Right? Now the proof. Required to prove. Triangle ABC. We always go to try the easy sounding one. ABC. Now, what is ABC? It is one stroke, X, two stroke. One stroke, X, two stroke. So there, you'll have to go one stroke, X, two stroke. So the name will be RPQ. Right? Watch again. ABC, one stroke, X, two stroke. So one stroke, X, two stroke. The name will be RPQ. RPQ. Alright, let me just do the other names in case somebody chose it differently. Suppose somebody said CBA. If you said CBA, then your other triangle will be QPR. And suppose you said BAC, one blank, then it will be PRQ. So there are many correct labels, right? So I'll just do the first one. I'll just use the first one, the proof. 1, 2, 3. So AB is equal to PR. Remember, in all examples it won't be given, just these examples everything is given. Angle B is equal to angle P, and finally BC is equal to PQ. Therefore, triangle ABC is congruent to triangle RPQ. Like I told you before, doesn't matter what label you use, the deductions will still be the same. So, A is equal to R. Have we used that in the proof? No. A is equal to R. It's not used yet, so it's a deduction. Angle A is equal to angle R. Angle B is equal to angle P. Angle B is equal to angle P. Angle B is equal to angle P. It is used on the top, so it can't be a deduction. Angle C is equal to angle Q. Let's see. Angle C is equal to Q. Is it used here? No, it's not used. Therefore, it is a deduction. And number 3. Now, two sides are already used. You can see that two sides are already used. So, obviously, AC is equal to RQ. So, AC is equal to RQ. You can see it in the name too. AC is equal to RQ. First to last. First to last. And finally, area of triangle ABC is equal to area of triangle RPQ. Okay, so that was number 5. Just giving you a few seconds to have a look at that. And well, you can always pause the DVD and check it out. I'll move on to number 6. Now in number 6, you are told that LO is equal to MP. You are told that LO is equal to MP. Then you are told that angle N is equal to angle R and they are 90 degrees. So this is 90 and this is 90. Right? You are told that these two angles are 90. And You are told NO is equal to MR. Now in this case, you don't worry about corresponding side. You only worry about the case. The case here is 90 degrees hypotenuse side. You can see the case. You have 90 degrees. You have the hypotenuse. If I just put the hypotenuse in a different color, you can see clearly that this is the hypotenuse. This is the hypotenuse. So it's a case of 90 degrees hypotenuse and one side. So your proof. Required to prove triangle. Suppose I do LNO. LNO is congruent to triangle. LNO is blank 1. So blank 1 will be PRM. Somebody else may have chosen something else. Suppose somebody chose this name. LON. If you chose LON, LON is 2, 1. So it will be 2, 1. So that will be PMR. And somebody else may have chosen with ONL. Yeah. Somebody can choose ONL. ONL. 1 blank. Then you'll go 1 blank, which is MRP. Proof. 1. Angle N is equal to angle R is equal to 90 degrees. That was given. Number 2. LO is equal to MP. That was also given. And number 3, NO is equal to MR. Therefore, triangle LNO is congruent to triangle PRM, and the case is 90 degrees hypotenuse side. Now the deductions. Number 1, I'll do the angles. And first one to first one. L is equal to P. Have we used that here? No. So angle L is equal to angle P. Next one. N is equal to R, but N is equal to R is used here, so it can't be a deduction. Last one. O is equal to M. Angle O is equal to angle M. Number 3. The sides. You can see, from the diagram you can see that that side and this side is already used. So the only remaining deduction will be that this side, Ln, is equal to PR. But you can see it here too. The first two. Ln is equal to PR. And number 4, the area of triangle LNO is equal to the area of triangle PRM. Right. Okay, just giving you a few seconds to have a look at that and to think about it before we do number 7. Right, we look at number 7 now. In 7 you are told that B is equal to Q. So you mark them. You are told that C is equal to R. And then you are told BC is equal to PR. Right, now this is a tricky one, so you got to be careful. So if you look carefully, you got two angles and a side. You got two angles and a side. But the rule says the side must be corresponding. What does that mean? This side is opposite blank. Therefore, that side supposed to be opposite blank, but it is not opposite blank, it is opposite x. So in these diagrams, the sides are not corresponding. You got two angles and a side, but the side is not corresponding. Therefore, triangles are not congruent. All right. With that, we will stop this little DVD on congruency. We've given you some very simple examples. Remember, in the exam and in the classroom exercise, or we might find you an exercise, we'll just do one more example, I think. I'll do one more example where everything is not given. Here, I missed out, so everything was given. Oh, here too, I forgot. Given, given. That was given, this was given. So I'll do one more now where everything is not given. And then we will end this. Alright, so that's the end of review of exercise 1. So I'll just do one more example after this. I'll call it exercise 2, where everything is not given, and you will have to determine whether the triangles are congruent or not. Alright, relax and enjoy.